Hello friends, myself Dr. Santimay Kundu. I welcome you the second lecture of soft computing techniques. So, in the first lecture, we have seen fuzzy sets, fuzzy membership functions, support, core, crossover points, and bandwidth of a fuzzy set. So, in this lecture, we will try to understand some examples of fuzzy set, alpha card, strong alpha card. We'll also solve questions for support, core, fuzzy subsets, cardinality of a fuzzy set. So this will be covered in this lecture today. So let's start with some example of fuzzy sets. As you know, fuzzy set is order pair. So let's write a fuzzy set. So let A equal to a fuzzy set A equal to something like, write a fuzzy set order pair A 0.1 to 0.2, 3, 0.6, 4, 1, 5, 0.6, 6, 0.3, and so on. So this is a fuzzy set. So you can define, let the x is the number of dishes. Suppose there are 4 friends taking food in a restaurant. So x is number of dishes, and mu x represents level of satisfactory. So my main motive is that how to construct the fuzzy sets. So if I say that x denotes the level of satisfactory, x set denotes the level of a satisfactory of 4 friends while taking food at restaurant. So creep set will not able to define the. So now the fuzzy set, by using fuzzy set you can write it. So this is one example of a fuzzy set. So there are many examples. So in that last class I gave edge tag. So please continue to solve the example of fuzzy sets. So now there are two ways to write the fuzzy sets. One, we are writing the fuzzy set as x mu x. So that is the set of a fuzzy set, where x is the element, mu x is a membership function, lies belongs to 0 to 1. Another notation is to write the fuzzy set A, which is that A equal to mu x by x, summation of that. So you can write like these things. So for this example, you can write the fuzzy set A as mu x 0.1 by 1 plus 0.2 by 2 plus 0.6 by 3 plus 1 by 4 plus 0.6 by 5 plus 0.3 by 6. So this notation is known as the Jade notation to represent fuzzy sets. So next is the Jade notation to represent the fuzzy sets. So you have seen that Jade so this is one more example. Suppose A denotes a fuzzy sets. So you can write 0.1 by 2 plus 0.4 by 3 plus 0.6 by 4 plus 0.8 by 5 plus 1 by 6. So that is a Jade notation of the fuzzy set. You can write the fuzzy set A as same as 2 0.1, 3 0.4, 4 0.6, 5 0.8 and 6 1. So you can convert the previous notation to the Jade notations. Next is some more example for support and core in terms of Z notations. Okay. Support, you know that mu x is greater than 0, core is mu x equal to 1. So let's take another example with Jadi notation. So if A is equal to 0.1 by 2 plus 0.4 by 5 plus 0.6 by 7 plus 1 by 8. So core support is that for the mu x is greater than 0. So support will be that numbers 2, 5, 7, 8. So core is only 8 because for this one. Okay. So I hope you have understood the support and core. A fuzzy set whose support is a single point in x with mu x is equal to 1 is called fuzzy singleton set. Fuzzy singleton set. So as for example, suppose you are drawing a diagram. So this represent x, this represent mu x. So suppose x equal to 5, the value of mu x equal to 1. So this is the fuzzy set 5, 1. So this is a fuzzy set. Now the support is a single point. So you can say that support of A is just 5. So this is known as a fuzzy singleton set. Now take another example. Suppose A equal to, this is x, this is mu x. Suppose x equal to 1. So this is the fuzzy set 1, 0.1, 2, 0.3, 4, 0.6, 5, 1. So you can take that x 1, 2, 4, 5 at 1 0.1, 0.3, 4 0.6, 5 0.1. So this is not a fuzzy singleton set because their support is 1, 2. Support of this fuzzy set, suppose this is B. So support of B is 1, 2, 4, 5, not a single set. So that is not a fuzzy singleton set. So now try to understand the alpha cut of a fuzzy sets. So there are two concepts. One is alpha cut, one is the strong alpha cut. So try to understand the set of elements that belongs to the fuzzy set, that belongs to the fuzzy set A, at least degree of alpha, fuzzy set of A, at least membership degree at least 2 degree alpha is called alpha cut. As for example, or the mathematically we can write that A alpha is equal to x belongs to x such that mu x is greater than equal to alpha. So that is the alpha cut, that is belongs to the creep set because there is only one element to this is only elements. So this is known as the alpha cut. Similarly, if I write that A alpha, so x belongs to x such that mu A x is greater than alpha. So this is belongs to, this is strong alpha cut. This is known as strong alpha cut. So you can write another notation like it is 18. So giving an example, suppose we write a equal to a fuzzy set a equal to 0.1 by 1, 0.2 by 2, 0.4 by 3, 0.6 by 5. Okay. So suppose the value of a is 0.2. So you'll get the element greater than that equal to, so 2, 3, 5, a 0.4, 3, 5. And if you write the strong alpha cut a 0.2, so greater than that, so you'll get only 3, 5 and so on. So by definitions you can say that a0 alpha cut with membership 0, this is known as support, and a1 this is known as core. So try to understand another question. Suppose I'm writing that A is a fuzzy set with 1, 0.2, 2, 0.4, 3, 0.6. So that A 0.2, 2 0.4, 3 0.6, 4 0.8, 5 1.0. So that is A. Now A 0.2 is 2, 3, 4, 5. A 0.4 is 2, 3, 4, 5. A 0.8 is 4, 5. A 1.0 is 5. So this is basically denote the support. This denotes the core. Okay. So I hope you have understood this example. Now the subset of a fuzzy set. Okay. Subset of a fuzzy set. So let X be the universe set A fuzzy set A is subset of a fuzzy set B if and only if so all membership value of A should be less than equal to mu bx. So for all x belongs to the x, and which you can denote A is a subset of B. And if similarly mu x is less than equal to mu bx, so you can say A is a proper subset of B. So graphically you can write like that. Suppose this is B, this is B, so A membership should be less than that, so it may be like this type of graph. So this is A, so you can say A is a subset of B. In numerical you can take one example. Suppose A something like 0.1 by 2, 0.2 by 3, 0.4 by 6. So B should be more than that. So 0.2 by 2, 0.3 by 3, 0.5 by 6. So this is the subset of a fuzzy set. Now complement of a fuzzy set. So the complement of a fuzzy set, the complement of a fuzzy set A is denoted by denoted by ever and is defined by and is defined by mu a bar x is equal to 1 minus mu x. So let's define a fuzzy set A. You can write 1, 0.1, 2, 0.4, 3, 0.6, 4, 0.8. So A bar will be 1 minus of that, so 0.9, 2, 0.6, 3, 0.4, 4, 0.2. So that is complement of a fuzzy set. Now convex of fuzzy set. So A is convex. A is a convex fuzzy set. Convex fuzzy set. Fuzzy set. If and only if for x y belongs to x, any two x y belongs to x, mu a lambda x plus 1 minus lambda y, the membership value of this point should greater than equal to minimum of mu a x and mu a y for all lambda belongs to 0 to 1. Graphically, this is the thing. Suppose this is x, universe x, so that is mu x. So you can write like this is the fuzzy set. So take any point x, any point y. So lambda x plus 1 minus lambda should lie belongs to that. So this value will greater than the minimum of this. So you can take this is a convex fuzzy set. Whereas if you take this example, suppose this is x, this is y, so its membership value of this point is not greater than minimum of these two. So this is not a convex fuzzy set. So non-convex fuzzy set. Because here is x, suppose this is the value. So this membership value is not greater than of that and this. So this is not a convex fuzzy set. This is a convex fuzzy set. Next is the scalar cardinality. So let x be the universe set, and A be a fuzzy set, be a fuzzy set. Scalar cardinality denoted as the same as that mod A is defined as the sum of the grade of membership of finite fuzzy set A. Grade of membership of finite fuzzy set A. Of finite fuzzy set A. That is mathematically coordinate of A is summation of x belongs to x all membership function mu x. Let denote write a fuzzy set A. You can write like that 0.1 by 1, 0.2 by 2, 0.3 by 3, 0.4 by 4, 0.5 by 5. So here cardinality of A is sum of the all membership. So 0.1, 0.2, 0.3, 0.4, 0.5. So that is basically 1.5. Okay. So in the conclusion, we have understood the things. First one is that the example of fuzzy set support core. Okay, fuzzy set, then support core examples. We have understood the fuzzy singleton set. Fuzzy singleton set. We have understood strong alpha cut, strong alpha cut, strong alpha cut. We have also understood that A0 alpha, so in the you take alpha equal to 0, so that is A0 means support, A1 means the core. Then we understood the fuzzy subset, convex fuzzy set, and we understood the cardinality, scalar cardinality, I mean the scalar cardinality. So now try to solve one question. So that question is that you write that x element x is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and mu x equal to x by x plus 10, x by x plus 10. So find the fuzzy set, find fuzzy set, and second is that if alpha equal to, so that is 0.33, so let alpha equal to 0.33. So find alpha cut, strong alpha cut. Okay, and these are the references for today's class. Thank you.